try something just a tad different this week. I'm going to try to do a couple days at once to try to just allow you guys a little more time to work at your own pace. So I'm recording a video today. This is continuing section 6.5, which we started on Friday. And if you remember, you watched that video and you were solving things like 5 to the x equals 3. And we didn't know the answer to that. Obviously, we couldn't just get a common base, so our strategy was to add a log to each side. And then properties of logs, exponents came down. And you could divide. So those were the problems we were doing last week. You had a Math Excel assignment for that. That is still open. So if you don't have that one done yet, please finish it up. Email me if you have any questions on it. So I'm starting the second piece of section 6.5, and I'm going to make one video, and this is actually for the next couple days. So I'm posting all this on Classroom as well to kind of clarify. I want to solve problems that already have logs in them. So I want to take something like 3 log base 4 of x equals 18. And I need to be able to solve for x. So we have to get our log by itself here first of all. So you have two options. You can either turn this 3 into an exponent, make that an x cubed, or you could divide each side of this equation by 3, which is probably a little bit easier here, although it really won't matter. So we have log base 4 of x equals 18 divided by 3 is 6. We've done some problems similar to this before. So if I want to get rid of my log, there's only a log on one side, so we're just going to change it to exponential form. So usually how I had you write that was if you start with your base, 4 to the 6th power equals x. Now if you get a really huge number, you're welcome to just leave it in that exponential notation. 4 to the 6th is reasonable. We can go ahead and multiply that out and we get 4096. You do need to make sure and check on these. Remember, when you're talking about a log, the argument always has to be positive, so make sure you are watching that, just like we did a couple weeks ago when we first started talking about logs. Okay. So let's say I gave you the natural log of 3x minus 1 equals 5.4. So if I'm trying to solve this, the base of a natural log we know is e. This log is by itself, so we can go ahead and change to exponential form. So e to the 5.4 equals 3x minus 1. If I'm trying to get my x by itself, I would add my 1. And final step would be to divide by 3. On the Math Excel, you have to watch if it asks for an exact answer. It would just be this e to the 5.4 plus 1 over 3. If I ask for a decimal, you're going to put that in your calculator. Make sure you put the numerator in parentheses. And if we do that, I like you to round to 4 decimal places. Again, on the Math Excel, just watch. It'll tell you what it wants you to do. And you get 74.1355. So there's the exact answer versus my decimal approximation. Again, quick check. When I put this in, 3 times that minus 1 is positive, so it's okay. When you plug it in, it has to be a positive number. Okay. let's say I gave you log base 3 of x squared minus 7 equals 2. Okay, we can change this to exponential. So 3 squared equals x squared minus 7. 3 squared is 9. Add your 7 over. Square root, when you add a square root, it's plus and minus, and the square root of 16 is 4. When you check it, 4 squared minus 7 is 9. That's greater than 0, so it's okay. If you take a negative 4 squared minus 7, you also get 9. So both of those answers work here. Again, we're checking that when we put it in, we have a positive argument. Okay, so hopefully these are a little bit familiar. We've done some similar to this before. I'm going to do a few more like this before we branch into anything new. Okay. Our properties of logs, or at least the definition of a log, only works if it's just a single log on that side. So I first have to combine these. Properties of logs, if those logs are added together, that means you multiply their arguments. So we get the natural log of x. When you're multiplying, you add those, so natural log of x to the 5th. Base of a natural log is e. So e to the 15th equals x to the 5th. To get rid of a 5th power, you do a 5th root. Because it's an odd root, you don't need a plus and minus. The 5th root would be e to the 15th. That's just like e to the 15 over 5 power if we wrote it in rational form, so your answer is e to the 3rd. And you could give me a decimal for that if you desire. Okay, so again, I've given you a problem where you have multiple logs on one side. Your first step is to combine those. So if these logs are subtracted, I put them together by dividing. So this is x minus 4 divided by x. Then we can use our definition. So we have 1/3 to the negative 2 equals x minus 4 over x. 1/3 to the negative 2. Negative would flip it and make it a 3. 3 squared is 9. So if you multiply over your x, subtract x, divide by 8, we get negative 1/2. Okay, remember, I failed to mention that on the last one, but remember, you're checking on these. If you plug a negative 1/2 in, negative 1/2 minus 4 is negative. You cannot do the log of a negative. So when I check that, I see it does not actually work. My answer is no solution. The argument has to be positive when you plug it back in. All right. one more like this. Okay, you have 2 logs added. When you do that, you put them together by multiplying the arguments. So this is x times x minus 6. Change to exponential. So 2 to the 4th equals, if I go ahead and distribute, that gives me x squared minus 6x. This is a quadratic, and we always set our quadratics equal to 0. So I will subtract over my 16. Because it's a 1x squared, we can just do our shortcut box method. If it's any other number, you know you have to do the full box. So you need numbers that multiply to negative 16, add to negative 6. So that would be a negative 8 and a positive 2. Set those equal to 0, so you get positive 8 and negative 2. We have to check. If I put in a positive 8, 8 is positive, 8 minus 6 is positive, so the 8 works. If I put in a negative 2, you get the log of a negative 2. We cannot do that. So x equals 8 is the only answer here. Right, this one is different than all of the others that I've given you because I don't just have a log on one side. Every single term has a log. My goal is to get a single log on each side. So I'm going to start by combining these logs. Because they are added, I will multiply. So x times x minus 4, or if you go ahead and distribute, that's x squared minus 4x. Now Friday, we were doing problems where we added a log to each side. It's also legal that you could take it away from each side. So if both sides have the log, just like when we did exponentials, you know, if you had 2 to the x equals 2 to the 4x plus 1, you got to drop the base. If you have the same log on each side, you can drop the log. So this becomes x squared minus 4x equals x plus 6. Okay, quadratic, so I'm going to set it equal to 0. So if I subtract my x, subtract my 6. Now I need 2 numbers that multiply to negative 6 and add to negative 5. So that would be a negative 6, positive 1. Set those equal to 0 and you get 6 and negative 1. But we have to check. Okay, if you plug a 6 in, 6 is good, 6 minus 4 is positive, 6 plus 6 is positive, so that's good. If I put in negative 1, I get the log base 1/6 of negative 1, and you cannot have that. So 6 is the only answer here. Last example. So I need to combine this so I have one log on each side. On the left, I have two logs that are subtracted, so I put them together with division. On the right, I have this 1/2. Remember, properties of logs, that will turn into an exponent. So this is like a 4 to the 1/2. We have a log base 5 on each side, so we can drop that. I'm going to go ahead and simplify. 4 to the 1/2 just means the square root of 4, so that's 2. So we can multiply by 2x on each side. If I subtract over my 3x, I get x equals -1. Check. 3 times -1 minus 1 is -4. You cannot do the log of a negative, so this does not work. It is a no solution. Okay. That is the end of my lesson for today. So there is, from Friday you had the Math Excel for 6.5 day 1. Now we have the day 2 portion. This is your Monday and Tuesday assignment, so this one is not due until Wednesday.